Knowing how to find the centroid, it's really important if you're taking the FE exam or if you're taking a statics class. Also, on the FE exam, you get at least one question on finding the centroid. And sometimes when we have to find the moment of inertia, we have to find the centroid first before we can apply the parallel axis theorem. So you guys must know how to calculate the centroid. So in this video, I'm going to show you guys how to find the centroid for this shape. Oh yeah, everybody now. Hey guys, my name is Kenza, and with my online courses, I've helped hundreds of students just like you study less, learn more, and pass the FE exam faster. So in this problem, we are giving this shape and we want to find the centroid about the x-axis. And by the way guys, if you want a video on how to find the centroid about the y-axis for this shape, go ahead and comment below centroid y and I'll make a video on that. Okay, so what I'm going to do here is I'm going to give you guys a hint on how to solve this problem, and then you're going to pause the video, you're going to attempt it, and then you'll come back and then check the solution. Now, remember, it's very important that you guys practice and attempt the problems because that's how you will know your mistakes and then also learn from them so that you don't do them during the exam, okay? Alright, so the first thing we're going to do here is we're going to go to the reference manual and we're going to grab the centroid equation, which is right here. So we have the sum of xn times an over uppercase A. Now xn, that's the centroid of each shape. You're going to multiply by the area of each shape and then divide by the sum of all areas. Now another thing to keep in mind when you're using this equation is that when we have a shape inside another shape, we actually subtract and we don't add, okay? Keep that in mind and I'll go over it more when we solve the problem together. Now, in addition to this equation, we also need to grab the centroid of the triangle, right? We all know the centroid of the rectangle is b over 2. But if you don't know the centroid of the triangle, you'll have to grab the equation from the reference manual. Now, we know that at the end of statics, there are tables that provide the centroid moment of inertia equations for different shapes. So we're going to go to those tables, and what I'm going to do is click dynamics and I'm going to go up and then get to the tables. This is the faster way to get to these tables. I also created a video on how to quickly go through the reference manual, which will save you guys a lot of time during the FE exam. If you haven't checked that video yet, make sure that you guys do, and I will leave the link above here, okay? So now if we go a little bit more up, we're going to find the equation for the triangle. And so this is the centroid of the triangle. So this is the equation that we're going to use, okay? Now with this information, this is the time where you guys will pause the video. You're going to give this problem a try and I will see you in a little bit. Before we start solving this problem, make sure that you guys download the unit cheat sheet for statics. This cheat sheet has all the units conversions that you must know. Okay, back to this problem. So these are all the equations that we're going to use to solve the centroid about the x-axis. Let's first start with this shape, the rectangle. So let's call it 1, okay? So the first thing we need to do here is the area. The area of this rectangle is going to be 9 inches times 14, right? So just 9 by 14. Then we're going to multiply by xn. Now xn is the centroid of the rectangle, which is just going to be half of 9, which is 4.5. Now let's take a look at the triangle. So for the triangle, because it's inside the rectangle, we're going to have to do minus here, okay? Keep this in mind. Then we're going to do the area for the triangle, which is just 1/2 times b, which is 4, and then times h, which is the height, which is 5. Now let's find xn for the triangle. So xn is going to be the distance from here all the way to the centroid of the triangle, right? Note guys how we have to add this 2 here. So the reason we have to add this 2, it's because we have to reference this shape to the origin. So this here is the origin, right? Because we're trying to find the centroid for the whole shape. And to do that, each shape that is not at the origin, we always have to reference it back to the origin. So that's why here we have to add 2, right? So going back to here, what we're going to do is we're going to do 2 plus the centroid, let's call this x triangle, the centroid of the triangle. And the centroid of the triangle, we're going to use this equation here, which is a plus b over 3. Now, a, it's going to be just half of 4, which is 2. So that's going to be 2 plus b. B is this whole distance, which is 4. And then we're going to divide by 3. Okay, so this whole thing is xn for the triangle. Now let's do the rectangle. So again, we're going to have minus here because we have the rectangle inside the big rectangle. And then we're going to do the area for the rectangle, which is 4 times 5. And then xn of the rectangle. So xn is going to be, again, the distance from here, always reference back to the origin, to the centroid of the rectangle. The centroid of the rectangle is just going to be half of 4, which is 2. And then we're going to add this 2 here, that is to reference it back to the origin. So here we're going to have 4. Now let's divide the whole thing by the total area. So first we're going to have 9 times 14, which is the area of the big rectangle. Then we're going to do minus. Remember guys, if we have minus here, you're going to have minus here as well. So we're going to do minus the area for the triangle, which is 1/2 4 times 5, and then minus the area of the small rectangle, which is 4 times 5. Now, before we plug in the numbers, let's check the units and make sure that they cancel. Again, if you guys haven't grabbed the unit cheat sheet, make sure that you guys do, because I do cover the units more in depth. So here what we have is we're going to have inch squared, because that's the unit of area, and then times inch. So we're going to have inch cubed. Now, all of these terms is going to have the units of inch cubed, because we have the area times x, which is inch squared times inch. Now here we're going to have inch squared because it's the area. Every term is going to have the units of inch squared. So then inch squared and inch squared cancel, and then we're left with inches, and that's the unit that we want, right? Now, if you guys plug in these numbers in your calculator, you're going to get 4.66 inches. So if we take a look at the multiple choice, the answer is going to be B. Now, if you guys enjoyed this video, don't forget to like, subscribe, and make sure you guys hit the notification bell so you don't miss out on any future videos. If you guys enjoyed this video, make sure to check out our online courses where we cover the exact material that you need to pass your FE exam. Our courses are lifetime access, provide step-by-step solutions, and relevant concepts and problems that will help you study less, learn more, and pass faster. Now, if you guys want more statics problems, make sure to check out this video right here. And thank you guys for watching. I hope you have a great week, and I will see you on the next video. À la prochaine. Oh, yeah. Everybody